Students, today we will be dealing with special theory of relativity. It's chapter 11 of your book, and we know that the kinematics was developed by Galileo and the mechanics by Newton. And Galileo as well as Newton successfully explained many physical phenomena such as planetary motion and certain observed properties of gases explained by kinetic theory of gases. It may be noted that here the velocities of the object involved is very small as compared to the velocity having high values. Suppose the velocity of light in vacuum. Now the kinematics developed by Galileo and the mechanics by Newton form the basis of classical physics. The classical physics and Newtonian mechanics have many terms that the physics began to think. That end of physics was in consideration, was in sight, particularly the understanding of planetary motion, the explanation of certain observed particles of gases in kinetic theory are noteworthy. However, a number of experimental phenomena such as photoelectric effect, radioactivity, black body radiation, etc. challenge the validity of classical physics. And this is where the advent of modern physics was under our topic. Now we can simply say that drawbacks of Newtonian mechanics gives a correct description of almost all phenomena normally encountered and miserably fails to explain the physical phenomena where the velocity of the object is close to the velocity of light in vacuum. Further, when the speed of the electron is comparable with the speed of light in vacuum, the mass so measured is not constant but increases with increase in its speed. So it means that we have to reassess the concept of mass as well as time when the object is moving with speed comparable with the velocity of light in vacuum. The mass starts increasing when the speed of the body increases. This is what we are going to notice or we are going to study. And for further knowledge of it, we must consider frame of references. Now the frame of reference fixed anywhere where the measurement of an event is called a frame of reference. It's a reference axis fixed and it can be fixed anywhere for the event measurement. And if a frame of reference is stationary or moving with uniform velocity, it is called inertial frame of reference. We have studied a word inertial in Newton's laws of physics. In first law of motion by Newton, we say that a body at rest will remain at rest and a body in motion will continue its motion with uniform velocity unless acted upon by an unbalanced force. and this law is also termed as law of inertia. So where inertial or inertia will be in our discussion, it means that a constant velocity, a uniform velocity case. So the frame of reference which is inertial is the one in which a body is stationary or moving with uniform velocity. It means it is the case of first law of motion. While the frames which are non-inertial, they will lacking uniform velocity. It means the velocity will be changing with time. And when the velocity change with time, we mean that there is an acceleration in it. So frames of references are accelerated when the velocity is changed, and these frame of references are also termed as non-inertial frame of references. Now another point for the difference between inertial and non-inertial is that frame of reference which is inertial is unaccelerated and non-rotating, while for non-inertial frame of reference it will be accelerated case. In our next lecture we will be dealing with Galilean transformation. Thank you.